All right, welcome back everyone. Today we're going to be looking at another non-parametric statistical test, which is the Wilcoxon signed rank test. When we last left off, we looked at the Mann-Whitney U, where we had two groups of unpaired data. And this time we're going to be looking at the Wilcoxon signed rank test, which is where we have two groups of paired data. So the objective for this lecture is to appraise if a Wilcoxon signed rank statistical test was appropriate for analyzing data provided in a scientific journal. So this test is a non-parametric rank test, which is analogous to a paired t-test. And so this means that samples are not independent, they are related. So this would mean that tests that we used before, such as the Mann-Whitney U, are improper for this type of data. In addition to being suitable for analysis of non-independent ordinal data, the Wilcoxon test can be used to analyze interval or ratio data that do not meet the normality or the homogeneity of the variance assumptions of the paired t-test. So this is where it would be applicable to our skewed continuous data as well as our ordinal data. Similar to other rank order tests, the size of the data samples affects the mechanism of calculating the test statistic W for the Wilcoxon test. And it's important to note that when 20 or more subjects are studied, the distribution of the W statistic actually starts to approach normality. So this is similar to what we saw with the Mann-Whitney U test. So to get right into an example to illustrate this, you are evaluating our miracle pain reliever drug in a group of patients who received placebo initially for their headache, and following a washout period, they are now receiving the miracle pain reliever drug for their headache. Pain scores were assessed after 1 hour for both the placebo and the miracle pain reliever drug and are listed as follows. Okay, so this time we have the same group of patients that are receiving both the placebo and the miracle pain reliever drug. So we have 7 patients in total here. So like we've done with other statistical tests, we want to make sure that no assumptions are violated. So sample sizes in each group compared are equal, and this is because we're using the same patients in both groups. So the same patients are receiving both the placebo as well as the drug. And all individuals are represented in both groups being compared. And since we're using the same group of patients for both the placebo and the drug, they are not independent, so they are related. We want to state the null and alternative hypotheses. So our null hypothesis would be that there is no difference in pain scores between the two groups. And our alternative hypothesis is that there is a difference in pain scores between the two groups. And when I say two groups this time, I mean the placebo group and the pain reliever drug group. However, it's the same patients that are in each group. We want to state alpha, which is 0.05. We would calculate our degrees of freedom, which, like the Mann-Whitney U test, is not applicable for the Wilcoxon signed rank test. And we want to find our critical W value, and for this we use a W table. Alright, so here is our W table here. And for the purposes of our example, we're going to do a two-tailed test. And we know that we have 7 patients. However, when we look a little further, what I'll get to in a second, is that the difference between two of our groups for one of the patients will end up being 0, so that kind of cancels it out. So our n ends up actually being 6, and I'll review this in a second when we go back to the example. We're going to be using an alpha of 0.05. And so our W value will end up being 0. Okay, so we saw from our W table that our W value is equal to 0. So similar to our Mann-Whitney U test, if our W test statistic is less than or equal to 0, then the null hypothesis can be rejected. So what we have to do next is calculate the W statistic. So we're back to our pain scores here. And what we do for each row, so each patient, is we take the difference between the two groups. So it'll be the placebo minus the miracle pain reliever pain score. So we get a difference, for example, patient 1, we get a difference of -1. Patient 2, 8 minus 3 is 5, and we do that all the way down to patient 7. like I mentioned before, there is one patient where there is no difference between the two groups and they get a difference of 0. So we do not include this group because there's no rank difference. We do not include them into the final analysis, which is why our N ended up being 6 instead of 7. Much like we did with the Mann-Whitney U, we rank the differences. So we look here and we have a 1 and a -1, and we disregard the sign for this case, and so we have a tie between these two, so they split the rank, so they'll each get 1.5. We skip over the rank 2, so the next highest one would be for patient 4 with a difference of 4, so this would get 3. Difference of 5 would get a rank of 4, and so on and so on. And so what we do next is we sum the ranks belonging to scores with a positive difference. So these will include all the patients except for our patient 1 because they have a negative difference, and again we disregard patient 6 because there is no difference between the two. So we add up all the positive ranked differences here and we get 19.5. Next we sum the ranks belonging to scores with a negative difference, and since there's only one of those, it will just be 1.5. So since 1.5 is smaller than 19.5, we would choose 1.5 as our test statistic. So this is similar to what we did with the Mann-Whitney U. Now we compare our test statistic with our W value, our critical W value. Since 1.5 is greater than 0, which is the value we found from the table, we cannot reject the null hypothesis. So there is no statistically significant difference found between the two groups. Again, there are online programs that we can use to calculate the W statistic for us. And again, I have already pre-entered all of the pain scores. So treatment 1 group would be the placebo group, and then treatment 2 group would be our miracle pain reliever group. Again, our significance level is 0.05, and we're going to be doing a two-tailed test. You can see here, they've calculated it for us as well, similar to what we did manually. And if we scroll to the bottom, under result 2 again, we find that the W value is 1.5, and the critical value for N equals 6 is 0. And so this means that the result is not significant at a level of 0.05. In the next set of lectures, we are going to be looking at a Kruskal-Wallis type test, so stay tuned for that.